What's up, 8th grade? Mr. Agnos here. This week we're going to start looking at what we call associations. So we have positive association, negative association, and no association. And what I mean um, is there a clear trend? Is there a clear pattern between two things that we are measuring? So I think it'll become really clear once you see the graphs here what I'm talking about. So let's go ahead and give me a blank graph here. So I'm going to click on each one of these, and then I'm going to come up with a real life example of each type of association. So the first is a positive association. So I click on this, and the basic idea, if we're looking at this from purely a mathematical perspective, right? So we have no context. Remember, this is my x-axis, and this is my y-axis. And if we think about it like this, right, and here's 0. As my x values get bigger, so as I move in this direction, okay, so I'm here, I'm here, I'm here, I'm here, I'm moving in to the right, what happens to my y values? Well, as I move to the right, my y values also get bigger. So if x is getting bigger, y is also getting bigger. And that creates, in this case, what we call a positive association. You can see it, and it doesn't form a perfectly straight line, but definitely we see that, hey, this is heading in this direction. This line, this black line I just drew, has what we call a positive slope, right? It goes up from left to right. So let's think about something that has a positive association. There are infinite number of things that have a positive association. One that I thought of was, okay, the amount of hours spent studying and test scores, right? So if on the x-axis I'm measuring hours spent studying, okay, and I don't even need any numbers. I really don't even need any numbers. It just means that, here's 0. It just means that, hey, if I'm at an x value here, it means I spent more time studying than if I had an x value here, right? Hours spent studying, and then test score we measure on the y-axis. You know what? Maybe I will put some numbers in here. I'm just going to make up some numbers, test scores. So maybe this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, this is a 10 by 10. So I'm going to say this is 100. Okay. So if you had a dot on this line, it would be 100%. And maybe this is hours. So this is, 1 hour, 2 hours, 3 hours, 4 hours. We'll say this is 5 hours, 6, 7, 8, 9, 10. All right. Well, you would fully expect that the people that study more, I'll just pick 2 points as an example. I'll pick this person, right? So this person, compared to the rest, studied very little, right? They studied for maybe about 2 hours, and so their test score was very low, right? So I'm just going to say low. They didn't study a lot, and they had a low test score. Well, let's compare that with this person right here who had the highest test score. They studied the most out of everyone, right? About 8 hours, and they had the highest test score. So we would say that the amount of time spent studying and your corresponding test score, maybe even just grades in general, have a positive association, right? The more you study, the better you're going to do in general. Now, where we're headed with this is we will start to model graphs like this with a line. We would then say, okay, boom, here's a line. What's the equation of this line? And then we could use that equation to say, okay, if someone spends 6 hours studying, what could we expect their score on the test to be, right? You can start making predictions like that. All right, so this is an example of positive association, right? Hours spent studying and a test score, right? The more you study, the more likely, again, nothing's for certain, but the more likely you are to have a high test score. All right, let's take a look at negative association. So notice that now my dots go down from left to right. We always read a graph from left to right. So the way you think about that is, again, remember this is the x, this is the y. here is 0. As our x values increase, so as x gets bigger, y gets smaller. Okay, as x gets bigger, right? This is the biggest x value on this dot right here has the highest x value, right? Maybe again since this is 10 squares, maybe this is like 7.1. That's like the highest x value on the whole graph, but it also has the lowest y value. And we could model this with a line that goes down from left to right. And remember what we learned about lines that go down from left to right? They have negative slopes. So I don't know what the slope of this line is, but I know it's negative, right? So when we have a positive association, we can model it with a line that has a positive slope. And when we have a negative association, we can model that with a line that has a negative slope, right? So this is negative association. When one thing gets bigger, the other thing gets smaller. So the example I came up with here was, okay, this is my x, and this is going to be number of video games purchased. So we're going to say number of video games purchased and on our y-axis we will measure money in our bank account. So I'm just going to say the money. I'm just going to say money. This is the amount of money we have. And you can see that as I purchase more video games, I have less money in my account. So let's take a look at some extremes here. This point right here. Again, it doesn't really make sense to have a decimal here. So I'm just going to round and I'm going to say, okay, this point right here, we're roughly at 7. So we'll say, okay, we purchased 7 video games, and we now have these numbers aren't realistic, but I'm just going to use them. We now have only $2 in our account, right? And again, I'm rounding. So here's 2, here's 7. Well, look at the opposite. Look at this point right here, right? The opposite extreme. This says, well, I only purchased 2 video games, so I have $9 in my account. So I bought less video games, so I have more money. That's what this point represents. This point says I bought more video games, 7, and so I have less money. And as I continue to buy things, the amount in my account, and again, as I continue to move this direction on my x-axis, I buy more and more video games. The amount of money in my account is going to plummet. This is Mr. Agnos's bank account, right? Because he's buying video games and computer parts. So the more video games, computer parts I buy, the less money I have. And we can model that with a line that goes down from left to right, and that line is going to have a negative slope. So that's what we call negative association, right? As x gets bigger, y gets smaller. And then the last one we have is what we call no association. It means there is no connection between the two things that we're measuring. You end up with dots just all over the place. There's no clear pattern or trend here. So an example of this, so here's my x-axis, here's my y-axis. If I were to say, let's go back to a test score, maybe I give you guys a test, and I said, okay, we're going to try and see, is there a connection between shoe size and your test score? All right, so in other words, does bigger feet mean a higher test score, and does smaller feet mean a lower test score, right? That would be a line like this. If I had a line like this, or I had dots that did this, it would imply that, hey, if I have size 15 shoes, I'm going to get a really high test score. And if I only have size 5 shoes, I'm going to get a really low test score, right? To use some extreme examples. Well, that is clearly not the case, right? Another example would be, okay, what about the opposite? Is there a negative correlation here? In other words, do people with small feet, I have a size 4, size 5 shoe, I'm going to score really high. And then if you have big feet, right, you're a big dummy, and you're going to get a low score. That's not true either, right? In fact, intelligence has nothing, or I shouldn't say intelligence, but maybe it's just how hard you studied, right? And how well you did on the test, how well you prepared. has nothing to do with your shoe size, right? There is no, and this is actually something that we would do in class. I would actually give you guys a little fake test or a little just a goofy test on something, and then we would actually create a graph like this and try and correlate. Is there a connection between shoe size and test scores? And there isn't, right? So we can't model, and that's important to know. We can't assume how someone's going to do academically based on the size of their shoe. All right, so those are the three types of associations that we're going to look at. So I think this is a pretty straightforward. You're going to look at these graphs and you're going to see a negative association, positive association, no association. Some of the questions just ask you, like, they describe a relationships. Like, do you think there would be a positive association between A and B, right? And think to yourself, as you read those questions, think to yourself, okay, if this gets bigger, what would I expect would happen to the other value? Maybe age and trees, right? As the tree ages, I would expect the tree to get taller. So that I would think that, so they would say the age of a tree and its height. You would think there would be a positive association, right? As it gets older, it's going to grow taller. Amount of coffee in a coffee pot. I would think that there would be a negative association, right? It starts full, and then Mr. Agnos comes along and he starts drinking the coffee, right? So as time goes by, the amount of coffee in the pot is going to go down. All right. Positive association, as x gets bigger, y gets bigger. Negative means as x gets bigger, y gets smaller. And then no association means there's no connection between the two whatsoever. All right. Hit me up in class with all your questions, and I'll see you guys soon.